Welcome to Formula 1 Maths. This is sample exam questions 003 for AQA Level 2 Further Maths. We've got 3 questions to answer. Question 1. 2a brackets 3x minus 5 plus 4 brackets ax plus 2 is equivalent to 40x plus b. Work out the values of a and b. So let's look at the left-hand side. So if we take the left-hand side and expand it, we're going to get 6ax minus 10a plus 4ax plus 8. Simplify it, you're getting 10ax minus 10a plus 8. So this left-hand side must be equivalent to the right-hand side, which is 40x plus b. We now compare coefficients. So on this side, the coefficient of the x is 10a. On that side, the coefficient of the x is 40. So they must be equal because the two sides are equivalent. So we have 10a is equals to 40. We can now solve for a and get 4. We now look at the constant terms. For the left-hand side, the constant term is minus 10a plus a. And for the right-hand side, the constant term is plus b. So we can equate those as well to get minus 10a plus 8 is equals to b. Because you know the value of a now, we can put the value of a in here to get minus 40 plus 8 equals to b. Solve that, we're going to get b is equals to minus 32. And so the value of a is 4 and the value of b is minus 32. Question 2. ABC is a straight line with AB to BC equal to 5 to 3. Work out the coordinates of C. Let's assume that the coordinates of C are A and B. So let's put in the ratios. So we've got 5 here and 3 over there. First of all, you add the two ratios. So I'll get 5 plus 3 equals to 8. Then to find the x coordinate of C, if I multiply 3 by the s coordinate, which is 2, and add 5 times the s coordinate of C, then if I divide it by the sum 8, I'm going to get the s coordinate of B. Let me repeat this. 3 times 2 plus 5 times A divided by 8 gives me 7. And so I get 5 times A, 5 times A, plus 3 times 2 divided by the sum of 5 and 3, which is 8, must give me the s coordinate of B. And so if I take 8 to the side, I'm going to get 5a plus 6 is equal to 56. And then I'll get 5a is equal to 56 minus 6. And then a will be equal to 50 divided by 5, which is equal to 10. So a is equal to 10. I'll do the same process with the y coordinate. So again, 5 times the y coordinate, which is 5b, plus 3 times the y coordinate, which is 9, divided by the sum of this, 5 and 3, will give me the y coordinate here. So I get 5 times b plus 3 times 9 divided by the sum, which is 8, will give me the y coordinate of b. Then if I take 8 to the side, I'm going to get 5b plus 27 equals to 32. And then 5b is equal to 22 minus 27. 5b is equal to 5, and therefore b is equal to 1. And so b is equal to 1. And that's the easiest way of doing it. There are other methods, but I think this is the easiest way of doing it. Question 3. Show that 4 cos squared theta is equal to 4 minus 4 sine squared theta. B. Hence, solve 4 cos squared theta plus 5 sine theta equal to 6 minus sine theta for all values in the range from 0 to 180. For this course, there are 2 identities that you need to know. And these are the 2 identities that you need to know. So the first one is cos squared theta plus sine squared theta is equal to 1. And the second one, tan theta is equal to sine theta over cos theta. We're going to use the first one to solve this question here. So from this one here, cos squared theta plus sine squared theta equals to 1. If I make cos squared theta the subject, I get cos squared theta is equals to 1 minus sine squared theta. So I can substitute this one in place of cos squared theta. So if I do that, I'll get 4 cos squared theta is equals to the 4, yeah? Then instead of the cos squared theta, I'm putting 1 minus sine squared theta. Then if I expand that, I'll get 4 times 1 equals to 4, and 4 times minus sine squared theta is equals to minus 4 sine squared theta, and that's the required answer. For B, hence solve this equation. So instead of this, I'm going to use 1 minus sine squared theta. And so this is 4 over here. Cos squared theta becomes 1 minus sine squared theta. Your 5 sine theta is still here. This is equals to 6, which is there, minus sine theta. Then I expand this one here. I'll get 4 minus 4 sine squared theta plus 5 sine theta equals to 6 minus sine theta. Then I'll make sure that the coefficient of the sine squared theta is positive. So I'll bring everything on this side of the equation to that side. And then when I do that, I'll get 4 sine squared theta minus 5 sine theta minus sine theta plus 6 minus 4 equals to 0. If I simplify that, I'll get 4 sine squared theta minus 6 sine theta plus 2 equals to 0. Then we can simplify this by dividing every term by 2 to get 2 sine squared theta minus 3 sine theta plus 1 equals to 0. This is a quadratic in sine theta. But because sine theta is a lot to write, we'll say let y equals to sine theta. So in that case, we have 2y squared minus 3y plus 1. So now we can easily factorize this. If I multiply 2 by 1, I'll get 2. Now I want 2 factors which will add to give me minus 3. So 2 factors of 2 which you add to give minus 3 will be minus 2 minus 1. So I know that minus 2 times minus 1 is 2, and then minus 2 minus 1 is minus 3. So I can then put those 2 factors to represent minus 3y, and I'll get this. Then I'll look at this term and this term. I can factor that easily to get this. And then I can see that these are common factors. So if I bring that one out, I'm going to get y minus 1 brackets 2y minus 1. If I solve that, or 2y minus 1 equals to 0. That means y equals to 1, or y is equals to 1 over 2, which is the same as 0.5. Now I know that y is equal to sine theta. So I go back and replace y with sine theta. So sine theta is equal to 1, or sine theta is equal to 0.5. It's time to solve for theta. That means theta will be equal to sine inverse of 1, and that gives 90 degrees. On the other side, Sine inverse of 0.5 will give 30 degrees. I want all the values in this range. There are two ways you can do this. You can either use a formula. So two ways. You use a formula, or you use the graphical method. I'll show you the two ways. So before I do that, let me get rid of all these scribbles. For the formula, we've got three separate formulas, one for each of sine, cos, and tan. For sine is this. The angle, theta, will be equals to 180 n plus brackets minus 1 raised to the power n times the angle that you got. In this case, either 30 or 90. So when theta is 30, I've got this. 180 degrees times n plus minus 1 raised to the power n times 30. Now, I'm going to use find the values of theta with different values of n. I'll start with 0. So when n is 0, 180 times 0 is 0, minus 1 raised to the power 0 is 1, so I end up with n equals to 30. When n is 1, 180 times 1 is 180, and then minus 1 raised to the power 1 is minus 1. So we get 180 minus 30, and we get 150. And so for this value, 30, we get two values. If I try 2, that would be outside the range, because if I put 2 here, 2 times 180 is 360. Then minus 1 squared is positive, so I get 360 plus 30, which is outside the range. I don't need that. That's why I stop at 1. When theta is 90, using the same formula, and n equals to 0, I'll get 180 times 0 is 0, and then minus 1 raised to the power 0 is 1. 1 times 90 is 90. Then if I try 1, 180 times 1 is 180. Minus 1 times raised to the power 1 is minus 1. And so I get 180 minus 90 is still 90. And so I get the same value. If I try 2, I'm going to go outside the range. So in the end, I get 3 values. The 3 values will be 30, 90, and 150. Now let's go and use the graph and see if we get the same. So for the graphical method, I have to draw the sine curve between 0 and 360. So I get that. Then look at this for 30. We got 0.5 here. 0.5 will be somewhere over there, knowing that the maximum you can get to is 1 and the minimum you can get to is minus 1. So let's put in 0.5 and draw the line over there. Now, this is the angle, the axis for the angle. So it means that at this point we have one value here, and at this point we have another value here. So that value is the first one we got, which is 30. And the second one will be somewhere over there. By symmetry, this length here is 30. That means this length here is 30. And I know that this length, this point here is 180. Let me write it properly, 180. And so if that is 30, this length here is 30, then 180 minus 30 will give us this value here. And so if I do that, I get 150. For the 90 degrees, if I draw the sine curve again, I have this. That is 1. That is minus 1. This is 0, 180, 360. This is 90. This is 270. Know that we got 1 here. And so 1 will be here all the way. and it's only one value we get, and that's 90, and that's where we got only one value. If we had gone beyond that, then we get more values for this particular angle, but we are restricted in this range, and so we get only one value. So two ways of getting this, the values are the formula method, which is this, and then the graphical method. And so that is the end of this session of sample exam questions 003. Thank you again for watching, and I'll see you in the next video.